Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome everyone into the Computer America Show. We are the nation's longest running, nationally syndicated radio talk show on computers and technology, and everyone, welcome into the program today. We have a great show planned for you where we have the one, the only Mr. Ralph Bond joining us here. He is our science and tech trends correspondent here for the show, and what that means, well, we'll get into that. But for now, everyone just sit back, relax, and just know that computeramerica.com is where you will find everything for today's show and really everything that we do here on the program. Go there at the top. There's a section for Ralph Bond, or it'll probably be one of the first posts that you see there when you first land on the site. And you can find the show notes. Super important because that will have pictures, links, hopefully pictures, links, and really everything that we talk about here on the program. So that if you're busy, if you're looking at something else, if you're commuting, whatever you may be doing, one place, computeramerica.com, find everything that you need to know. So, with that being said, let's go ahead and just bring Ralph on, and yeah, we'll have fun with it. So, again, today we have Ralph Bond. He is our science and tech trends correspondent once again. And Ralph, welcome back onto the program. How you been?
And for people who are brand new listeners or watchers of the show, let me set the stage as I do every week to kind of give you an idea of what we're up to. So what Ben and I do each Friday is highlight 4 articles that show us key trends and developments in a wide range of things. Of course, artificial intelligence, robotics, medical technology, sustainable energy technology, transportation advances, agricultural technology, construction tech, space research, physics, on and on and on, you name it. But most important of all, here's the key. We're going to give you an oasis of positive news thanks to the world of science and technology.
And I really do value, Ralph, that when you come on the show that you, do highlight, maybe once in a while you throw in a story that, made a lot of headlines, but a lot of these fly under the radar or, just really aren't covered in general by, larger publications. So
right.
Odds are, ladies and gentlemen, you probably haven't heard of these 4 stories, but you should. So, Ralph, I say we get started with story number 1.
Yeah, this one is great in the world of recycling. It comes from techexplorer.com. Get this headline. No sorting needed. Plasma torch shows promise for hassle-free plastic recycling. We all know that I think everybody knows that the biggest challenge in recycling plastics is sorting it out. Sorting out the acceptable plastics and so on and so forth. It's a big, big challenge in the world of recycling. Sometimes done by hand, which is just what? Anyway, this is a great story coming out of South Korea. So researchers at the Korea Institute of Machinery and Materials have developed the world's first plasma-based chemical recycling technology that can process mixed waste plastics, that's the key, mixed waste plastics, without sorting or the need to remove paper labels from the plastic bottles, etc. Wow.
It really, recycling plastic is, one of those things that I try to do, but at the same time, there's like 7 different kinds. And, you said, there's all the prep work. It's a nice thing to do, but at the same time, what a headache. And I think everyone can agree with that. So a solution is needed.
Yeah, exactly right. And again, salute to the South Korean scientific community for coming up with this. So this process uses hydrogen plasma, a superheated ionized gas, to break down mixed plastic waste into reusable chemicals like ethylene and benzene, both key building blocks for new plastics. And real quick side note, one of the things I do in the show notes, Ben mentioned this in passing, come out to computeramerica.com. Each of the stories we document my notes, but I also insert things where I feel there's a need to answer my own questions and maybe give you additional information. So regarding ethylene and benzene, ethylene is used to create polyethylene used in plastic bags, bottles, containers, and insulation. Benzene is used for packaging, foam, utensils, and for electronics, lenses, and adhesives. So two extremely important elements, again, ethylene and benzene. And what this process does is it creates those two elements out of mixed plastic waste. And get this, the process temperature range used to do this this plasma torch, 1,832 to 3,632 degrees Fahrenheit. And for the rest of the world, that's 1,000 to 2,000 Celsius. Whoa, hot.
That's super hot.
Yes, it is. And the process, how long does it take to do this? 0.01 seconds faster than you can blink your eye. And the fuel source. Yeah, go ahead, Ben.
Yeah, just saying, it just instantly vaporizes.
Yes, yes.
That's crazy.
In the blink of an eye. Faster than that. And the process fuel source, 100% hydrogen, which suppresses carbon soot formation. So it's a pretty darn clean process as well. And the plasma torch exploits rapid energy transfer and something called bond dissociation kinetics to instantly convert polymers into simpler molecules. It's a clean, controlled reaction with minimal byproducts. And bond dissociation kinetics, which my last name is Bond. I thought immediately they were talking about my mental process. No. Bond dissociation kinetics refers to the rate and mechanism by which a chemical bond breaks, typically under thermal, photochemical, or catalytic conditions. So that's the principle underneath this, breaking down the plastics almost instantaneously into the two very useful building blocks we talked about a moment ago.
Yeah, it's really sounds like it's just taking no matter what kind of plastic and just instantly just breaking it down into its associated parts, and it makes a lot of sense. Obviously, I'm sure we're gonna get into kind of the scalability of it, but it seems very so complicated, but you needed something complicated to break apart multiple kinds of plastics. So yeah, it makes sense.
Yeah, it is pretty cool. And actually, come to think of it, I hadn't really thought about this, and I should have researched this as well. You know how it is when you look at the bottom of a plastic bottle or something, you see the little triangle and you see the 1 or 2 or 5 or all these different numbers and so forth, right? And at least in our recycling here in our community, it says, well, we can take 1s and 2s, but we can't take the other guys. What I didn't find out, and I should have found out, and it'd be fun to find out, is if this new plasma torch process that the South Koreans have come up with, does it take any plastic, no matter what number is assigned to it? That would be key. If it does, that's even more profound than I originally thought about, come to think of it. Pretty cool. For sure. Yeah. And then going on with the story, by controlling the reaction temperature and time, the researchers achieved selectivity levels of 70 to 90% and ethylene yields exceeding 70%. And then after purification, more than 99% of the output could be secured as high purity raw materials for plastic manufacturing. Again, to wrap it up here, the big news is this method eliminates the need for manual separation, which is a major bottleneck in conventional plastic recycling. So salute to our friends in South Korea for another amazing scientific achievement.
Honestly, anything that has to keep me from reading the faint little, 1 through 7 here. And and honestly, I remember even in America, well, really, in America, we have 1 through 7. I believe in other countries, like in New Zealand, I think I'm oddly familiar with this. They have 1 through 14.
Oh, wow. Okay.
Yeah. So they have a lot of different kinds of plastics and, what they were used for and whatnot. So anything to get rid of that headache would mean recycling is easier to do, which is more likely that people will do it, which is better for everyone. So yes, great breakthrough. It seems simple. Honestly, it seems like the opposite of simple, but the payoff could be really good. So story number 1, let's go ahead and jump on down to story number 2 if you're following along in the show notes, because again, those are available by the time that you hear this. They're up on the site. So story number 2, let's talk a little bit about, Limitless energy. I've only heard that a handful of times here with Computer America, but this one from MIT. So
Yes.
who knows? Maybe they're right.
Yeah, this is a great one. This comes from the Cool Down, which is part of the MSN.com news feed. And the headline here is MIT Spinoff achieves major milestone in pursuit of limitless energy beneath our feet. We're talking about geothermal energy, folks. Subhead here could fundamentally change how we power our world. It's a pretty powerful statement, but it's it's a pretty cool story. So let's get into this here. Again, it's all about geothermal energy, which offers limitless heat from beneath the Earth's surface. And you think, okay, again, what's the heat for? Well, you use that heat to bring water to a boil and steam point that can drive the generation of electricity. Okay, so that's why geothermal is so exciting. This could dramatically expand grid output, reduce costs, and eliminate reliance on fossil fuels. So that's, again, the motivation for geothermal. Now, I inserted a little comment of my own here at this point. The news here has to do with a radical alternative to current technologies for drilling deep into the earth to tap geothermal energy. And below, I've inserted a recap of current technologies and techniques. We won't go into super detail here. You can come out to the show notes and get the details if you wish, but there are 3 common techniques right now: rotary drilling, very conventional; air drilling, which is interesting; and coiled tubing drilling. So those are the 3. You can learn about that in the show notes. But here's the news. There's an outfit called Quaise, that's Quaise, Quaise Energy. This is an MIT spinoff. Has successfully drilled 100 meters, that's about 330 feet, approximately into, and my notes say super hot. It really should be more like warm, because at that depth, we're not really getting to the super hot rock yet. But if they've been able to drill 100 meters, again, 330 feet approximately, into rock using millimeter wave technology. That's the radical alternative to the conventional drilling techniques. And this is the first time such drilling has succeeded outside a lab setting, marking a major milestone. Pretty cool stuff, Ben.
I was just thinking that, like, millimeter wave technology, it sounds like something that, it's how Marvel would explain one of its characters that's able to, do the things that they do with their super suit. But to be able to, they said they were able to get 100-meter hole, so it must be working pretty well.
Yeah, pretty cool. And here's a comparison here. The technique uses millimeter waves to vaporize rocks. So instead of a drill with a drill bit grinding through the rock, no. Technique uses millimeter waves to vaporize rock at temperatures around 752 degrees Fahrenheit. That's about 400 degrees Celsius. And the millimeter waves are high-frequency electromagnetic waves between 30 to 300 gigahertz with wavelengths between 1 to 10 millimeters. Wow.
So I was able to find, just through a basic Google search, find this picture. And this is actually from the LinkedIn profile of the CEO of Quaise. And this is what it looks like after they kind of drill this thing. Very smooth, because it's essentially kind of just vaporizing, melting the rock. Not your typical drill hole. This thing looks, almost like carved or something was, kind of molded around it. It's very interesting.
Yeah, that's a great image. That's a good one. And so here's how this works. Dielectric, heating, similar to microwave ovens. Millimeter waves heat rock by exciting molecules, causing them to vibrate and subsequently break apart. This vaporizes the rock into a fine ash. Wow. And the way it's, the mechanism at the heart of this is something called a gyrotron source. So a device called a gyrotron generates millimeter waves. These are powerful enough to reach temperatures that melt or ablate tough basement rock like granite and basalt. And a quick side note, a gyrotron is a high-power vacuum electronic device that generates coherent electromagnetic radiation in the microwave, millimeter wave, and even terahertz frequency ranges. So that's that core mechanism that's behind this drilling. And the waveguide delivery, how do they control this? Well, the millimeter waves are transmitted down a metallic pipe, a waveguide, to the rock face. The beam is focused to maintain energy density and precision. And the benefits of this non-contact drilling, again, very traditional drilling, you have a drill bit and it's grinding away. No, here's the benefits of this completely non-contact approach. Unlike mechanical bits, millimeter waves don't touch the rock. This eliminates wear and tear, allowing deeper penetration without tool replacement. Again, traditional drilling, you got to replace the bit or so forth. It's going to wear out and all this fussing around. All that goes away with this. And in terms of the ash removal that's generated by this process, a circulating gas flushes the vaporized rock ash to the surface, keeping the borehole clean and stable, as your image showed, a very clean borehole. Remarkable stuff.
This article from New Atlas has a number of pictures from their test, and shows some of the vaporized rock, and this is the plug that they kind of pulled out. If you're watching the video portion, highly recommended. But just seeing the some of the more traditional looking drilling parts, but the results are certainly, you can see here, this is different types of granite and different basalt rock and whatnot that they're able to kind of drill through, and it just, Ralph, look at that. Just look at,
I know.
Vaporize kind of means one thing, but to see just melted granite, which I take as, heat proof, is incredible.
Oh, yeah. And that's good. Would you add that link into the show notes? Because that's a very good article. All those images. That's fantastic. Thank you.
Yeah. So, it seems like, and they even show like the rig and how big it is. Like, this is sometimes, Ralph, we cover things that are like in a lab and they take up, essentially like a broom closet, and they kind of set up their tools.
Yeah.
And they, get cool results. This is anything but. This is a huge installation that they've kind of set up, and, something a little bit beyond proof of concept. This is,
that's true.
This is real stuff, and I hope to see more of this, because I have heard in the past, Ralph, that geothermal is something that could power individual homes, if not entire neighborhoods, if done properly and if kind of scaled up. So It's good to see another type of green energy getting new advancements to hopefully come to more people. So. Oh yeah,
geothermal is a win-win-win all the way around.
For sure. So, well, although honestly, here at the house that we're at, moved in 15, 20 years ago, we had geothermal and we actually took it out. It's because the person who put it in, like, the house was kind of newish, but they put in a 20-year-old geothermal pump. So the technology's been around for a couple decades, but then by the time we got to it, efficiency and new technology matter a lot. So, newer geothermal is amazing, but just like anything, older technology has to be replaced with newer technology. So,
there you go.
I love the breakthroughs, and it's really cool to see what Quaise is doing with their stuff. So, there you go. Story number 2. And there's even a link to a YouTube video that we didn't show on video. So, check that out in the show notes. Story number 2. Story number 3, let's go ahead and jump on down, and let's talk about, Micromotors. And, it may seem like what they're putting into the new Honda Civics, but no, these are even smaller than what you can get into a Honda. So, Ralph, story number 3.
Yeah, this is a remarkable story. It comes from ScienceDaily.com. Headline: Scientists build micromotors smaller than a human hair. And the subhead here is: tiny, light-powered gears could revolutionize medicine by powering machines the size of human cells. Normally, our last story of the show is medical related. In this case, we're going to have 2 in a row. And this is just remarkable. You look at the image. This is infinitesimally tiny little gears that you're looking at if you're looking at the show notes. It's just remarkable.
They look so clean. And, the way it's like the gear, the teeth, everything kind of links together. Yeah. But then you start to realize the scale, because something like it looks like a clean plastic molded thing. But something's a little off. And I think it's the scale, it's the size.
Yeah. So here we go. Scientists at the University of Gothenburg in Sweden have built the smallest on-chip motors ever so far, with gears just 16 to 20 micrometers wide, smaller, as we said before, than a human hair. Wow, these gears are made of silica and etched directly onto a chip using traditional lithography. That's kind of interesting. So they're using a traditional, well-established process. Instead of mechanical drive trains, the gears use optical metamaterials that respond to laser light. Time out. This is very geeky stuff, folks. Do I fully understand it? Absolutely not. But it's it's pretty interesting. So again, a little side note, what are optical metamaterials? Well, artificially structured materials designed to control electromagnetic waves, specifically light, at scales smaller than the wavelength itself. And there's more information about optical metamaterials in my show notes if you want to geek out some more on that. But we'll skip over that and get back to the story. So here's how this works. Laser intensity controls the speed. Polarization controls the direction of these little gears and motors, if you will. This enables motion without physical contact, allowing for rotation, linear movement, and even light deflection via micro mirrors. Again, folks, very geeky stuff. The big thing to keep in mind is we're talking about mechanical process, or motors, if you will, smaller than a human hair. And what can you do with that? That's the implication. So previous gear miniaturization failed at 0.1 millimeters due to mechanical limits. No surprise. This light-driven approach, however, breaks the size barrier, opening doors to complex microsystems. And these micromotors could act as, so here's the payoff. What do you do with this? These micromotors could act as pumps or valves inside the human body, regulating flows at the cellular level. Their size and precision make them ideal for lab-on-a-chip systems, nano machines, and targeted therapies. And here we have a quote to wrap it up from one of the lead researchers. Quote, "This is a fundamentally new way of thinking about mechanics on a micro scale." So again, super geeky, but check it out. If you're a real geek, you're going to love this one.
Yeah, just looking at the images, I mean, it is the building blocks of, kind of motors and gears and whatnot.
Yes.
Which, I don't even understand engines and how they work, on the macro scale. So to see them the size of the human hair is something, I'm definitely not going to understand. But still, like, I don't know. I hope that someone can come up with something like this. It just seems, I don't know, very rudimentary, I guess, to begin with. But this is obviously what you need to kind of get to the next step of, like you were saying, controlling everything on a chip, cellular level engineering. Yes. Incredible. I have no idea where they're going to go with it, but very incredible.
Yeah.
So there you go. And again, the pictures say 1,000 words, so check out that or check out the video. So story number 3, story number 4, let's go ahead and let's talk about, well, like you said, medical news story number 3, medical news story number 4. And yeah, this is, we've had some amazing brain news. And I will say, even before we get to this one, Ralph, just like 2 days ago or yesterday, they said that they said cured. I think they've improved the longevity of those with Huntington's disease.
Oh, interesting.
Yeah, so it was the first time that they were able to improve the quality of life throughout their entire life. So what used to be a couple of years has turned into a couple of decades. So they're essentially saying they have cured Huntington's disease, because by the time that the disease starts to, really take its effect is about the time people usually fall ill due to other illnesses. And Ralph, I was looking at that, and they said that the cure was gene therapy. And after a quick 12 to 18 hour brain surgery, where they're doing stuff in there, and they apply the gene therapy directly to the brain, but they're able to cure Huntington's disease. So there's a lot of amazing research and a lot of breakthroughs going on with the brain. So this, I think, kind of goes in. This could feed into it in the future. So
yeah, and you're so right. If you want to be encouraged, given a reason to get up and keep going every day, gene therapy in the world of science is so remarkable. And every single day, it's impossible to keep up with all the developments and all the research and all the wonderful things that are happening. But let's get back to story 4 here for today. This comes from sciencealert.com. Headline: New ultrasound helmet reaches deep inside the brain without surgery. Now, if you have the show notes and you're watching us or come out and get the show notes, you can scroll down and look at the picture of this device that shows a patient volunteer lying down on it looks like those scanning devices where they put you in the tunnel-like deal. It's a big, giant apparatus. So it's not like this little football helmet or something you just pop on your head. No, it's something you're lying down. You're connected to this device. So, very, very intense.
Yeah. So your image that you have in the show notes and also on the site here, it has things like a face cushion, face mask, clamping bolts, gasket. Like it's a whole thing.
It's very impressive machine, but nonetheless, what it can do is really, really cool. So let's get into this. Deep brain structures like the basal ganglia and thalamus wield major influence on our behavior. If something goes awry, dysregulation in the deep brain may trigger neurological conditions like Parkinson's disease or depression, for example. Now, despite the clear importance of these structures in the brain, our knowledge about them remains limited by their location, making them difficult to study and or treat. So here we go. In a new study, researchers from University College London, in collaboration with the University of Oxford's Nuffield Department of Clinical Neurosciences, together, they've created a paper that documents a new device that might offer an alternative to invasive procedures. Featuring a novel ultrasound helmet, it not only modulates deep brain circuits without surgery, but reportedly can do so with unrivaled precision. And I want to stress again, when they say helmet, take it with a grain of salt. It's really quite a large apparatus.
For sure.
And then here's how the ultrasound helmet targets the brain. This is amazing. The helmet uses an array of 256 ultrasound emitters arranged inside its shell or casing. These emit focused beams that converge precisely on deep brain targets. It can stimulate regions 1,000 times smaller than conventional ultrasound and 30 times more precise than other deep brain devices currently available. Amazing achievement. And targeting mechanism, how does this work? A soft plastic face mask stabilizes the head, ensuring accurate delivery of ultrasound pulses. And it also features real-time monitoring. The system is compatible with fMRI, that's functional magnetic resonance imaging, allowing researchers to observe brain activity as it happens. There's your real time. Wow. And to wrap things up, one of the lead researchers noted, quote, the ability to precisely modulate deep brain structures without surgery represents a paradigm shift in neuroscience, offering a safe, reversible, and repeatable method for both understanding brain function and developing targeted therapies. Wow.
I mean, smaller, more precise, and repeatable. I mean, that's all great things you want to hear when it comes to brain surgery.
Yes.
This seems like one of those technology things that, like right now, I'm sure someone put a lot of effort into the look of it. Ralph, I'm sure in 2025 it's going to look like this, something that looks like it could be like a Frankenstein costume, where it's kind of the big square flat top head. But I'm sure in the future it's just going to get smaller and smaller and more accurate until it can become widely available. So this is amazing, and it's and the pictures really do show a whole lot. So yeah, you love new therapies. So amazing stories, and again, the world of medicine I think offers some of the best breakthroughs that we can that we can bring you when it comes to technology. Not to say that other fields don't, but Okay, so that's story number 4. And ladies and gentlemen, if you have been following along, you may notice that it doesn't end there. That's only about half the show. Well, the rest are honorable mentions. These are articles that Ralph finds, typically another 4 or so, that, we just try to keep the show a bit more condensed and try to keep it to about half an hour for ease of listening. But that doesn't mean that more stories aren't out there, that there isn't more good news. And some of these definitely could have been in the top 4. I mean, it's not even, okay, I just said top 4. In the 4 at the top of the show notes. These are all just as good. It's not a ranking system, but hey, let's at least, Ralph, give them the headlines so that if they want to find out more, they can come out to Computer America, they can find the show notes, and it's right there towards the bottom. So yeah, honorable mentions.
Okay, you got it. Here's the first of 4 from good old Popular Mechanics. Headline: NASA is testing a nuclear battery that could last 433 years. Okay, that's pretty cool. Check that one out. The next one is from interestingengineering.com. Headline: China's transparent coating to turn ordinary windows into solar power generators. And there's so much research worldwide about how can we make exterior buildings, and particularly windows, play a role in generating energy, and this is a great step forward coming out of China. So that's a good one. Next one here comes from gizmodo.com. Scientists pitch bold plan to turn nuclear waste into nuclear fuel. Tapping into discarded nuclear waste could help generate a self-sufficient source of a key ingredient for nuclear fusion. A new plan proposes. So this is quite geeky, but really a good one. Check that out. And our last one is from zmescience.com. Headline: this is really curious stuff. When I read the headline, I said, this is wild. Scientists made jelly ice that never melts. Oh yeah, and it's edible, compostable, and reusable. You've got to read this just to find out what the heck's going on. A hilarious little image they provide with this too.
looks very cool, and they even spelled out jelly ice there in the image. So yeah, no, it's really incredible. And hey, maybe coming to a drink near you. So ladies and gentlemen, the music means that we're going to wrap it up here. I want to thank Ralph for, of course, as always, putting this together, putting in all the work, and it's really fun to do these every single Friday and really lead out every Friday on a high note, because these are stories that, with the news cycle, we could probably talk all day long about bad stuff. But hey, this is some good stuff, and we hope that you really enjoyed it. So Ralph, thank you again. Everyone out there, thank you for tuning in. Thank you for listening. And until next time, Ralph joins us every Friday to talk about all of these. And until next time, do something fun, have a good weekend, and we'll catch you next time. Everyone, have a good one. Bye-bye.